ProbStats kids, welcome to week 6 Monday with Dr. Callahan. Go ahead and pause your video to go ahead and answer the following 3 questions. Keep in mind that your warm-up blog is going to be due on week 9 Friday. This is week 6 Monday. So you have about 3 more weeks before the 300 points are due. All right, let's go ahead and take a look at this. Remember, going back to geometry, anything that has an angle that is greater than 90 degrees, it is considered to be an obtuse. Anything that is going to be equal to 90, it is right. An angle that is less than 90 is acute. And an angle that equals 180 exactly is straight. Then take a look at your answers for solving the equations. Make sure you know how to do this because it will be on your ACT, especially if you're planning on going to college. You should be signing up for those exams. All right, so last time I saw you guys, we talked about the most common probability scenarios. Before we get started with theoretical probabilities, there are certain things that you need to know. And the 3 different probability scenarios are: 1, if you're going to be using a dice, which there are 6 faces. So your theoretical probability is always going to be out of 6. The second scenario is if you have a deck of cards. Even if you don't play cards, you should know what the faces are or what cards are consisted in a deck of cards. So your theoretical probability is going to be out of 52. And from the deck of cards, you need to be well aware how many kings there are, queens, and jacks, and you know that there are going to be 4, and you need to know that within a deck of cards, there are 4 kings, 4 queens, and 4 jacks. There are also 13 sets each of the cards itself, 13 sets of spades, 13 of hearts, 13 of diamonds, and 13 of clubs. And in each one of these, there's a king, king, and a king, and that's why you get 4 for kings, 4 queens, and 4 jacks. Half of those 52 cards will be black cards, so half of 52 is going to give you 26, and similarly, 26 red cards. So how many cards are there total? 52. The next part that you guys usually go over is a coin toss. With this one, it's fairly simple. It's out of 2, obviously, because you could either have head or tails. All right, last time you guys had your homework from your textbook on your Google Doc, go ahead and take a look at your answers, pause the video. Make sure this is documented on the back of your packet on the homework template. All right, let's go ahead and get started with today's stuff. Today I'm going to do a review of permutation combination, fundamental probability, in addition to your theoretical probability. Your homework tonight is to do 11.4, number 28 to 48 evens. Make sure you guys go to week 6 Monday of the Google Doc to find the textbook picture. And these are the 3 questions that we're going to go over. Question number 1, number 2, and number 3. So go ahead and take a piece of paper and just copy them down. All right, so let's go ahead and take a look at this. It says a museum has 7 paintings by Picasso and wants to arrange 3 of them in the same wall. How many different ways are there to do this? Well, they want to rearrange 3 of them on the same wall. So then looking at this, the order does matter. So in which case, we're looking at a permutation. So our permutation is going to be the following equation. we're going to have the two numbers. Your bigger number is always going to be N. Your smaller number is always going to be R. So then I have my permutation 7 and 3, which is going to equal to, it's going to be N factorial, which is 7 factorial, divided by N minus R factorial, so 7 minus 3 is 4. And you just need to go ahead and simplify this. So then here I have 7 times 6 times 5 times 4 factorial divided by 4 factorial. My 4 factorial is going to cancel, and so my answer is 7 times 6 times 5. 6 times 5 is going to give me a 30. 3 times 7 is a 21, but don't forget your 0. So there will be 210 ways to rearrange 7 paintings by Picasso if I were to select 3 of them on the same wall. And of course, if you need to go ahead and have a different explanation, there is a video right here on the very bottom that you guys can go ahead and watch as well. Next question, how many different ways can you rearrange a letter in the word lollipop? This is the one where you have repeats of letters in a word. So it is the one where you have an N factorial over a Q factorial times R factorial, S factorial, T factorial, so on and so forth. But these letters in the bottom are going to be the number of repeats in your word. This part on top is going to be the total number of letters in the word itself. So let's go ahead and take a look at this. My N in this situation is going to be counting how many letters are involved in the word lollipop. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is that. Q is going to be the first word that's repeated. In this case, it is the letter L. So how many times is the letter L repeated? Once, twice, 3 times, so it's 3. R is going to be the second letter that's repeated in this problems. And in that case, it's an O. So how many times is O repeated? 1, 2. Then my S is going to be the letter P. And how many times is the letter P repeated? Twice. And I think that's it. I don't need to worry about the I because there's only one I, and I don't care about that. So with this information, let's go ahead and plug it in to the equation. So I have 8 factorial over Q, which is 3 factorial, times R, which is 2 factorial, times S, which is 2 factorial. And that is going to give me 8 times 7 times 6 times 5 times 4 times 3 factorial over 3 factorial times 2 times 1 times 2 times 1. I can now cancel the 3 factorial out, and now I just have to divide a few things. 8 divided by 2 is going to give me a 4, so cross those out. 6 divided by 2 is going to give me a 3, so cross that out, and that's it. 1 is in my denominator. In my numerator, I still have 4 times 7 times 3 times 5 times 4. So then if you have a calculator, you can go ahead and multiply that out. Four, 3, 7, 5, 4. So this is going to give you 12. 12 times the 4 is a 48. 3 times the 5 is a 35. $48 and 35 is going to give you 1,680 different arrangements of the word lollipop. All right, let's go on to the next question. Question number 3. A person playing poker is dealt 5 cards. How many different hands could the player have been dealt? Okay, so then looking at this right here, given the fact they're dealing with 5 cards and it doesn't really matter which 5 cards it's going to be, this is going to be one where the order does not matter. So in which case it will be a combination. And with a combination, your formula is going to be n factorial over n minus r factorial times r factorial. So 5 is going to be my r. How many hands are there in a deck of cards? There are 52 cards in a deck. So 52 is a bigger number. That will be my n. Now let's go ahead and plug this in. 52 factorial over 52 minus 5, which is going to be a 43 factorial, times r factorial, which is 5 factorial. Oh, you know what? I actually subtracted this wrong. Sorry about that. That is going to be, so 50 minus 5 is 45, so 47. All right, let's go ahead and proceed forward. 52 times 51 times 50 times 49 times 48 times 47 factorial. I have a 47 factorial already set up, but then I have to extend out the 5. So 5, 4, 3, 2, 1. Take your 47 factorial and go ahead and cancel that out. And now that we have this done, we just need to go ahead and simplify with division. 50 divided by 5 is a 10. 48 divided by 4 is a 12. 52 divided by 2 is going to give me a 26. 51 divided by 3 is going to give me a 17. So what numbers do I have remaining? Well, I have 26 times 17 times 10 times 49 times 12. And if you have a calculator for that, you will have a really big number, which is 259,960 different ways of doing this. So lots of probability, lots of possibilities. And that's why when people try to attempt to count cards, I'm like, good luck with that on blackjack, because this is a lot of different ways of memorizing this. All right, you guys, with that said, that concludes our summary for week 6, Monday. Make sure you guys do your exit ticket, and it says express yourself. Everyone has an opinion. Think about what you learned today and then form an opinion around the topic discussed right below what your opinion is, and be sure to back your opinion with support and reason. If you need some additional support on this, as always, you have my link for the Google Doc. This provides you a summary with everything that we've done since the beginning of week 1, Monday. If you need to take a look at our homework assignment for this class, today is week 6, Monday. You just simply scroll down all the way to the bottom to look for week 6. So I'm going to go up a little bit. So week 6, Monday is actually right here. And then you would like to go ahead and take a look at the homework assignments right here on the bottom. If you need some additional assignments, I do have a Kahoot, a quizzes on practice of combination and permutation. And then if you need some additional videos, and it might actually be wise if I actually share this with you. So let me go ahead and do that. Let me share this over here. Let's see. Here we go. And where is my ProbStats? Here we go. So you should be able to see this right here. This is your week 6, Monday, which is right here. The different Kahoot and the quizzes, your textbook right here. And then of course, if you need some additional videos, if you would like to go ahead and get some extra practices, YouTube is always one of my favorite tools to use because there's a countless number of videos on permutation and combination. So just type in combination, permutation, and the fundamental counting principle. And as you have it, there are plenty of examples here that also has videos for you guys to kind of look at. I'm going to go ahead and include this in the assignment right here. I'm going to put other videos, and I'll include the link right there. So that way you have it readily available. Okay. So then in addition to this, there's one other thing that I need to go over with you guys, which is your assignment, which is right here. Now we have pretty much kind of been finished with permutation combination. So you guys have a quiz that I would like you guys to work on. Now this is what the quiz look like. It's just 5 questions, 2 points apiece, 10 points altogether. You will never have anything that's worth more than 10 points. It's always 10 in the grade block, and you already have 4 grades inserted in Infinite Campus. So you might want to check on that. And to access this, you just go to your MS team, go to your ProbStats, and it says week 6 Monday assessment on probability. So you want to click on the viewed assignments, and you should be able to see something that looks like this. You click on it, and ta-da, there you are. If you don't have a printer, it's not a problem at all. All you have to do is just show me the work on a separate piece of paper, take a picture of it, and then just upload it onto MS Team. All right, you guys, I hope you have a wonderful week. I will see you guys next time.